This is John Black, Super Chemist. Here to do a real simple video. I wanted to just put something up um, about why I would use a carbonate when I need a hydroxide. I have some examples down there. If you look at the first two equations, well, the first and the third, you see that I have an acid plus a base. Okay, an areneous acid, meaning protons and OH, negative. Um, so you see, an acid and a base makes salt water, right? So hydrochloric acid and this first one, sodium hydroxide, I have sodium chloride and water. Now, you see right below it, I use sodium carbonate instead, right? And doubled up on the acid, 2HCl plus the sodium carbonate yields the same thing, but doubled. Double the salt, same amount of water, and one extra thing, carbon dioxide from the carbonate. Okay, and that's why you double up on the acid, because you need two H's. On the first one, you get your H from the acid and the OH, right? H2, and then your O comes from the OH, H2O. But here you don't have your OH, so you need two H's over here to make up for the H that you would have had on the OH. It's the only difference. See how it makes the same thing? It makes salt water. The only difference is it makes CO2 also. And you'll see on the carboxylic acid, I have acetic acid or ethanoic acid. Uh, I'm neutralizing it with the base sodium hydroxide. Same thing, I'm making salt water, sodium acetate and water. If I use the carbonate, I make the same thing. I double up on the protons because I don't have an H on here. I just have an extra O. And then I get the CO2. See how it does the same exact thing pretty much? I'm not saying you can use, they're interchangeable on every reaction in the world, but I'm just saying there's a lot. And the reason why, on another, I used to make chromate, uh, potassium chromate, I used chromium hydroxide. By the time I'd used it, if not all of it, at least half of it was carbonate. You know what I mean? Chromium carbonate. But it doesn't really matter because I want you to look down here. It's self-auto ionization of water. All water has a little bit of OH negative in it and a little bit of protons. And by protons, I mean H3O positive. You don't actually have protons floating around or jumping around from water molecule to water molecule making H3O. But look down at the bottom. So I have your water, your proton, some negative OHs. Well, look what happens when you put sodium carbonate into that water, okay, or any carbonate. You'll have a little bit of carbonate and you'll have a little bit of sodium. But look at that. You have a hydroxide and a sodium in water. So you literally have and make sodium hydroxide every time you put a carbonate into water. You know what I mean? That's what that pH 7, But anyways, that's why you can use it a lot of times, even though you don't have the hydroxide, or you have hydroxide and it's just all contaminated by the CO2 from the air and it turned into carbonate, most of it. It doesn't really matter, because when you put it into water, you will have some OH negatives in there, and when they get used up, by the reaction, the water will make more OHs, because there's going to be a certain amount of OHs in the water no matter what. So anyways, it's just a little tip, I guess, or a little whatever, just to get something out. I still have a couple more videos. They're kind of rushed, so they're not the best, but I'm going to put them up little by little or whatever. Anyways, y'all have a great day, and always remember, science is great.